Okay. Last video lecture we have discussed about the hydropower station and the site selection. Now in this video we are going to discuss about the classifications. About the topics covered in this presentation are classification of hydropower plants. What is the base? What is the how to classify the hydropower plants based on some of the categorized advantages, disadvantages of hydropower plant, as well as the applications, important applications of hydropower plants. First, we are going to discuss about the classification, how the hydropower plant has been classified. Classification of hydropower plants. Classification of hydropower plants. What is the hydro classification means? Hydropower plant are classified according to availability of head, quantity of water, nature of load. Based on this only, it has been classified based on available head and the quantity of available quantity of water, maybe nature of load. What type of load is according to quantity of water available. First, runoff river plants without pondage. Runoff river plants without any pondage. Next, runoff river plants with pondage. Next, reservoir plants. Runoff river plants without pondage, runoff river plants with pondage, and reservoir plants. Next, runoff river plants without pondage. In this type of hydroelectric power plant, the available water from lake, river, lake is not stored in the pond. There is no stored facility is not there. Whenever the storage facility is not there, they can available the water within a season only. The water should not be used in unrainy seasons. This capacity of such plants depends upon the rate of flow. Whenever there may be a rate of flow, it has been used the power. Otherwise, they can't give any. Such plants run during a rainy season only. During the unseasons of rain is there. Only discharge water can help to run the power plants. But in case of rainy season, it should be use the output power, base loads. Next, runoff river with pondage. Now, with pondage means there may be a which is opposite to that without pondage. In this type of plant, in this type of hydroelectric power plant, the available water from lake, river or lake is stored in a pond. In this type of hydroelectric power plant, the available water from river or lake is stored in a pond. Now, whenever there may be a storage, that storage water can be used in, there may be no rainfall also. Okay, during the year of entire. Now, due to the storage of water in pond, it is useful to run the plant during the peak of as well as non-peak of periods also. Whenever there may be no rainfall, we can use the water, storage water. There may be rainfall. By using of rainfall, we can use the discharge. The capacity of such plants, such type of hydroelectric power plant, depends upon the size of plant. The capacity of what type of hydroelectric power has been generated depends upon the size of a pond. Now the size of pond is large, it produces more electricity. When the size of pond is very less, during a off-peak period, it produces less power of electricity. Reservoir plants. Generally, our plants are reservoir plants. Reservoir stores the water, potential energy. In this type of hydroelectric power plant, reservoir is provided. This reservoir is useful to store a ample quantity. Ample quantity means huge quantity of water during rainy season. When rainy season is there, there may be storage of water, plenty of water available is there. This is useful throughout the year. Whenever there may be no rains are there, during a summer season also, they can use the water throughout the year. Whenever there rain rainfall, they can store the water. Such type of hydropower plant has better capacity. Now reservoir plants has better capacity. This type of hydroelectric power plant may used base loads, may be used as a base load plants. Hydroelectric power plant may be used as a base load plants also. Look at here, a reservoir is there, nothing but a river. We can store the water here, reservoir. Now I construct a sluice gate is there. Sluice gate, whenever there may be a full of water, we can rise. There may be a full of water. The dam gets damaged. Dam get collapsed sometimes. That's why during a rainy season itself, whenever there has been raise the gates, and during the raise the gates, that flow has been flows through the penstock and strikes the turbine. The turbine has been strikes. Whenever the turbine strikes, the generator has been runs. Whenever the generator has been runs, it produces the electricity. Now hydraulic power, by striking of turbine, converted into mechanical power. Useful mechanical power. Mechanical power is useful for all the types of energies. Mechanical power, and has been generated by electrical by using of generators. Now powerhouse, where the electrical quantities are available. And it is a draft tube. Draft tube is generally maintained in a reaction turbine. That's why you are placing Francis turbine. That our Nagarjuna Sagar dam also consists of a Francis turbine. It's a medium head. Nagarjuna Sagar is a medium head. That's why Francis turbine. Francis turbine is a reaction turbine. There may be a thread in order to increase the pressure. That's why you are providing draft tube here. Now, whenever the water has been comes out from the draft tube, then water has been moved to the tail race. Now it is a head race, it will be the tail race. The water has reached the tail race. That's why reservoir plants has been stores the potential energy during a peak period, otherwise peak off period. Next, according to the available by head, according to the head availability, low head plants below 30 meters, medium head plants 30 to 300 meters, and high head plants above 300 meters. Above 300 meters, there may be the plants are high head plants. Based on the head of the plant, we can use the turbines also. We have to use the turbines. Okay. Low head turbine, we have to use axial turbines. Medium, we have to use reaction turbines. For high head, we have to use impulse turbines. Next, what is low head turbine? Low head plant. A low head power plant stores water by construction of dam across the river. Otherwise lake. The powerhouse is installed near to the base of the dam on the downstream side. It is constructed. There may be a dam by using of concretes that construct the dams. The powerhouse is installed near the dam on downstream side of a site. Next, the barrages with regulate gates are provided to flow the excess water in the river. The barrages are constructed over the low head plants. Whenever the barrages has been constructed, the excess water in a river or lake, gates are provided. Now it is a low head power plant, head race. Dam is constructed over the head race. Now it is a penstock. Whenever open, it has been goes in a penstock and strikes the powerhouse. There may be a tail race. Now the powerhouse which is nearer to the dam. The powerhouse is which is nearer to the dam. That's why you have to provide the powerhouse here, which is very near to a house. There is to be as low head power plant. The head is very low. That's why it is called as low head power plants. Next, medium head plants. If available water head is in between 30 to 100 meters, okay, otherwise 300 meters, the plant is said to be as medium head plant. Water is laid to the turbine from the forebay by the penstock. Now there may be excess of water when there may be a medium head compared to low head. There may be excess of water. That excess of water has been stored in forebay. That forebay has been possible. That forebay water has been passed through the penstocks, which may be steel. Penstocks are made of steel, otherwise a concrete materials also. Forebay also stores the rejected water and loads on the turbine decreases. Forebay stores the rejected water and as a load on the turbine decreases. When the load on the turbine decreases, the forebay is used to send the water. Now it is a reservoir is there, main reservoir is there. It is maybe a high head, maybe a medium head. Whenever the forebay has been stored here, the forebay has been stored the water here, remaining water, which has been tail race here, and through the forebay, the water has been passed to the powerhouse. It has been passed to the powerhouse, and powerhouse has been strikes the turbine. Turbine has been generates the electricity and passed through the tail race. And now there may be load decreases. Now that maybe it decreases in load, the forebay has been sends the power water and strikes the turbine and rotates the, and the water has been goes to the tail race. This is a mountain region. Generally, these are constructed over a hilly mountains. Next, high power plant. If available head is more than 300 meter, which is above 300 meter, the plant is said to be a high power plant. Now, in a civil works, including such tank, whenever there may be a high head, whenever there may be a medium head, we have to use forebay. And in a high head plant, we have to use such tank. What is the use of such tank? Means the function to meet the sudden change in requirement water caused by fluctuations in the load system, and there may be a flow of pressure is there, water pressure is there. In order to relieve the water pressures in a penstock, water pressure in the penstock, we have to use which one? A such tank has been used. We have to use a such tank. Now it is a high power plant. Reservoir is there, reservoir dam is there, dam has been constructed. Tunnel is nothing but a passage of water across the mountains. Passage of water across the mountains. Such a source tank is nothing but such tank. By the tunnel, it has been go past through the penstock. Now penstock is consists of high pressure. In order to relieve the high pressures, we have to use such tank here. Okay, such tank is mountained across the penstock anywhere. You can place anywhere. That relieves the which one? Pressures inside the penstock. Then strikes the turbine, use the output power. Next, according to the nature of load, base load plants, peak load plants, pumped storage hydroelectric load. Based on the availability of load, what type of load is available? Maybe peak load or base load, otherwise pumped storage. Base load plants. The univarying load which occurs almost whole day on a station. Unvarying load, continuous load which occurs almost whole day on the station. Whole day on the station is known as peak load. The constant load which is occurs whenever the constant load has been occurs during the whole day of a station is called as base load. The base load on a station is almost constant in nature. That means uniform continuous load is nothing but a constant. They have largest capacity. Base load have largest capacity as well as load factor. The producing of electricity factor also. Next, peak load. The various peak demands of load over above the base load on a station is known as peak load. And there may be a continuous power is there. Whenever there may be increase during the rainy season, there may be increase. The increase in power is nothing but a peak load power. These peak demands on station is generally small part of total load, may occur throughout the day. Peak load. Runoff river plants with pondage. Without pondage, with pondage means continuous power has been given during a unseason also. Now load in time in hours. Now it gives a base load, it gives a constant power during the season. It has been used throughout the day. And base load kanna whenever there may be increase above the base load, that is called as peak load power plants. Next, pumped storage hydroelectric power plant. This type of power plant is used less amount of water available. This type of power plant is used where less amount of water is available, and there may be less water is available. We have to use pumped storage tanks. This storage from head trace pond is useful for generation of electricity. Whenever there may be water has been passed away to the tail race, that water also again used. That water also again used by using of pumped storage plant. By using of motors, there has been pumped back. Now during a peak of period, off peak period, that means during a very hot summer season, the storage water from tail pond from the down region is pumped to a tail race pond again with the help of a barrage. Again the water has been pumped back with the help of a now these are pumped storage tank. The cycle is continuously repeated. That's why it's called as pumped storage. Because the water is again pumping back to the head race. That's why it's called as by using again storage has happened. Pumped back by using storage happened. That's why pumped storage hydro layout. It is a layout. Now it is a general layout of hydroelectric power plant, and the tail race pond is there. Tail race water is there. Tail water. After that, again dam has been constructed here. Now it stores energy. It may be a reservoir. Now it gives the end. Now whenever the stores reservoir, again it has been pumped back. Reverse tendering has been happens. Whenever reverse tendering happens, it has been pumped back to the head race pond. The stored water has been sent to the during the half peak periods during the summer seasons. This water has been again used by dam. Now they use the power continuously. This cycle is goes on repeated. That's why it's called as pumped storage. This is a very important one. Pumped storage. Next, advantages comes to advantages of hydroelectric power plants. Stations. First, the operating cost of thermal power plant is less when compared with thermal and other power plants. Whenever the operating as well as less skilled is necessary, not skilled persons are not necessary. Operating cost is also very less compared to thermal plants, because they will be less capable of using. That means no boilers, that type of not is there. That's why operating cost is less. Next one, in case of hydroelectric power plant, no need of fuel. Fuel is not necessary. Why? Because without there may be no fuel, no smoke, no pollution. No pollution hazards to the water pollution is not there, as well as air pollution is not there. Next, comes to hydroelectric power plant, efficiency is higher than a other power plant. It gives higher efficiency when compared with other power plants. Doesn't change the age of plant. Efficiency doesn't vary whenever there may be increase in the age, there may be no change in the efficiency. Hydroelectric power plant gives quick response to the change of load compared to the other power plants. It gives a response time is very high of low to compare with thermal power plants. Hydroelectric power plant is a pollution proof. No pollutions. Pollutions are very less. Disadvantages. What are the disadvantages? Main site selection is a disadvantage, as well as investment. First, the investment of hydroelectric power plant is much more than thermal power plant. The investment is high because you have to build the dams like that. Dam should be more. Polymerum is also constructing lot of time. That's why investment is more. Power generation by hydroelectric power plants depends upon the water availability. Power generated by an hydroelectric power plant on water availability. The power generation depends upon the water availability only. Without water, they can't generate electric power. That means which depends upon the natural phenomenon of time. There may be no rainfall in the year. No hydroelectric power has been produced. That is one of the disadvantage. Time required for the construction of the plant is much more than the thermal power plant. The time also requires more because we have to construct dam. Dam has been takes years of time for construction in order to construct the dams, and we have to site the mountains, port bays like that, like tunnels. Time is also more. Next, comes to applications of hydroelectric power stations. Major applications, we are discussing about the major applications only. To control the flood in the rivers. Flood. We can stop the floods. Next, water for irrigation, for agriculture, as well as for fisheries. We have to use the waters for fishery purpose, for agriculture purpose, for the husbandry purpose. We have to use irrigation, use waters. Small hydropower plants, where there may be small hydropower plants up to 10 megawatt, is used for surveying industrial plants. Now this water has been also used to the industrial power plants. Next, micro hydropower plants, that is very less when compared with small. They give for an isolated homes. There will be individual homes are there. They provided water for usage of water during a summer season. The water is very less. That's why they give it for isolated homes as well as small community kilowatts. To store and supply drinking water, it has been stores the water and also supplies the drinking water to the homes and also for industries. This is about the classification and advantages and disadvantages of hydroelectric power stations. Okay, this about hydroelectric power station classifications, advantages and disadvantages.